So far, you've seen integrals of the form maybe one number to another, and some continuous function on the interval, something like this. Obviously, the antiderivative would be sine x evaluated from 1 to 2 with the bounds plugged in. Sine of 2 minus sine of 1 will be our area under the curve. Now we're going to look at problems like this. 1 to 2, 1 over 2x minus 1, 2 to the 3 halves x. Change this up a bit to 1/2 is our upper bound. Okay, so we might be tempted to just integrate this thing and plug in the bounds because that's what we've done the last 2 courses, but it's not enough to do that anymore. We have to look at this function and decide where it's discontinuous. So remember that when you have division, you can't divide by 0. So think about what x values will make this denominator 0. You see that one of them would, or the only one would be 1/2. So x cannot be 1/2. Well, 1/2 is our upper bound on our integral. So we have to treat this instead as a limit problem, and we'll just change it a bit from 1 to 1/2, and we'll take the limit as x goes to, well, not x, we'll use different letters, so we'll change the upper bound to maybe something like b. You can use anything you like. So the limit as b goes to 1/2, and then we'll just rewrite the function. So it's the same exact problem. When b goes to 1/2, this upper bound becomes 1/2. So it's the same problem, but we have to treat it like a limit because we don't want to ever actually reach 1/2, or we'll be dividing by 0. So we're curious to see if this area actually converges to a number or if it just gets infinitely big, and we'll see what that means. So at this point, we can actually take the antiderivative. We'll rewrite it a bit first just to be safe. I like to rewrite my integrals as something like this, 2x minus 1, the negative 3/2 dx. Now I remember my shortcut. I don't have to do u substitution. What I can instead do is integrate this using my regular power rule, add 1 to the exponent, and divide by that, 2x minus 1. Add 1 to the exponent, so you get negative 1/2. And we're going to divide by negative 1/2, which is the same as multiplying by negative 2 over 1. And then because you have a linear function on the inside, you're going to divide by 2. And this is our antiderivative. We'll clean this up a bit. Well, we're going to evaluate it from 1 to b. But we'll clean it up a bit. Cancel these 2's. We'll just have 2x minus 1, negative 1/2, evaluated from 1 to b. Keep going. 1 over 2x minus 1 to the 1/2. I like to have a positive exponent. It just makes it easier to work with. So we move it back down to the denominator. Okay. Again, evaluated from 1 to b. So now we just plug in the bounds like usual. Limit really doesn't come into play until the very last step. Everything else is the same. So 1 over 2b minus 1 to the 1/2 minus 1 over 2 times 1 minus 1 to the 1/2. Okay, so obviously this right side is just 1 over 1 to the 1/2. Well, this is 2 minus 1, so that's 1 over 1 to the 1/2, which is of course just 1. But this left side, when you plug in 1/2, you're going to have 1 over 0 to the 1/2. Can't do that. So what we say is that this diverges. So had we originally started this problem, done the antiderivative, and just plugged in the bounds, we would have gotten a very incorrect answer. So just be aware of your function and on what intervals it is continuous or not.